From 30,000 feet, the ocean looks calm, a vast, endless blue, textured only by the faint shadows of clouds sliding slowly across its surface. To a pilot, the view is reassuring, predictable, ordinary. The gauges hum their soft, electronic song. The engines maintain their steady, powerful rhythm. And yet, this is how almost every disappearance in the Bermuda Triangle begins. Not with panic, not with violent storms, but with absolute normality. Flight plans are filed, departure times are logged, radios are checked, and then rechecked. Crews exchange casual remarks as they cross an invisible boundary in the western Atlantic, a rough triangle formed between Florida, Bermuda, and Puerto Rico. There are no warning markers here, no change in the sky, no sign that this stretch of airspace has swallowed more aviation mysteries than almost anywhere else on Earth. Then something small happens. A compass needle hesitates. It doesn't spin wildly. It doesn't slam against its casing. It simply pauses for a fraction of a second. It refuses to agree with itself. Magnetic north drifts. True north no longer aligns to an experienced pilot. This is unsettling, but it's not unheard of. Instruments fail, that's why there are backups, but in this region, the backups often disagree with each other. One compass points west. Another insists north is somewhere else entirely. Gyroscopes, which should remain rock steady, begin to drift, slowly and silently, forcing pilots to make constant corrections just to keep the aircraft level. Navigation charts, which are perfectly reliable everywhere else, suddenly feel inadequate, as if the sky itself has shifted. The radio crackles. A pilot makes a routine position check. The voice on the other end responds, slightly distorted, asking them to repeat. The signal fades in and out. Static crawls across the channel, like something alive. Words arrive late, or sometimes not at all. None of this is dramatic, it's subtle. And that is what makes it so dangerous. In aviation, confusion is far deadlier than fear. By the time most pilots realize something is truly wrong, they are already improvising. They cross-check their fuel consumption, they adjust their headings, they reassure their passengers no mayday is called, no alarm is raised after all. Nothing catastrophic has actually happened. Yet then, the horizon begins to lie. Over the open ocean, visual reference is everything. There are no mountains, no roads, no cities to guide you, just the sky and the water, meeting at a clean, but deceptive, line in the Bermuda Triangle. Pilots have long reported that this line behaves strangely. It rises, it falls, it tilts, just subtly enough that the human eye accepts the illusion without protest. The aircraft is perfectly level, the instruments say so, but the pilot's own senses scream otherwise. This deep conflict between the machine and human perception is where disappearances are born. Our brains are wired to trust our vision over numbers on a screen. When your inner ear says the aircraft is banking, and the horizon appears angled, a pilot may unknowingly correct for a turn that doesn't exist. The aircraft then begins a slow, tightening spiral, so gentle that it still feels like straight, level flight. This phenomenon is known as spatial disorientation, and it can happen anywhere. But over the Bermuda Triangle, it appears with unusual frequency, and often, without any warning. Military pilots have described flying through air that feels thick, as though the resistance changes from one moment to the next. Commercial crews have reported their altimeters fluctuating without reason, showing sudden gains or losses in altitude that vanish just seconds later. Even time itself seems unreliable, watches disagreeing by minutes, fuel consumption not matching the distance traveled. And then there is the silence. The single most chilling detail, found across decades of aviation reports, is not what was said, but what wasn't. Many planes vanish without a single distress call, no screams, no final, frantic transmission, no broken sentences, cut off mid-word, just silence. Air traffic controllers wait for routine check-ins that never come. Radar returns fade away. Not abruptly, but gradually, as if the aircraft is simply drifting away rather than falling out of the sky. Search and rescue teams are dispatched, combing thousands of square miles of empty ocean. They expect to find debris, oil slicks, floating luggage, but often, they find nothing. No wreckage, no bodies, no trace of fuel. The ocean gives no answers. One of the earliest and most famous cases happened in December 1945, when 5 U.S. Navy training aircraft, a group known as Flight 19, disappeared during a routine navigation exercise. The weather was favorable. The pilots were experienced. The mission was simple. And yet, radio transcripts revealed their confusion building minute by minute. The flight leader reported that everything looks strange in the ocean. Tragically, Even the rescue plane sent to find them vanished as well. What unsettles investigators is not that planes crash. Aircraft fail, pilots make mistakes, storms appear unexpectedly. Those are all known risks of flying. What troubles them is the pattern. The Bermuda Triangle doesn't just take planes during violent weather. It doesn't only target old aircraft. It doesn't discriminate between military and civilian, experienced or novice, and most unnervingly, it rarely leaves behind any evidence. This region is one of the most heavily traveled air corridors on Earth. Thousands of flights pass through it safely every single year. That fact is often used to dismiss the mystery entirely. But for those who disappear, statistics offer no comfort. Something about this place seems to magnify small errors into fatal ones. Something interferes, whether it's with instruments, human perception, or both, just enough to push an aircraft off its course, without anyone realizing it. Until it's far too late, the sky remains clear. The engines keep running, and somewhere between known coordinates and the open ocean, the plane simply slips into history, leaving behind only questions, distorted radio logs, and a stretch of airspace where our most advanced technology seems strangely fragile. The surface of the Atlantic hides its intentions well. From above, the water appears uniform dark blue, gently rippled, endless. But beneath the Bermuda Triangle lies one of the most geologically active and chemically unusual regions of ocean on Earth. It's not a single anomaly, but a layered system of quiet instabilities, all stacked one on top of another, and the ocean is not as still as it seems. Far below the surface, trapped within sediment and ancient rock formations, are vast reserves of methane gas. Far below the surface, trapped within sediment and ancient rock formations, are vast reserves of methane gas. This methane is not harmless. It exists under immense pressure, locked in ice-like structures known as methane hydrates. This methane is not harmless. It exists under immense pressure, locked in ice-like structures known as methane hydrates. As long as the temperatures and pressures stay stable, these hydrates remain frozen in place, embedded deep in the seabed. As long as the temperatures and pressures stay stable, these hydrates remain frozen in place, embedded deep in the seabed. But stability is not guaranteed. Seismic activity, undersea landslides, shifting currents, or even gradual warming can cause these hydrate deposits to destabilize. When that happens, the methane gas is released violently, rising upward in massive plumes that expand as they race toward the surface. When this methane erupts, the ocean itself changes its behavior. The water density drops suddenly. Buoyancy just disappears. For ships unfortunate enough to be sailing above, this can be catastrophic. A vessel floating over a methane plume can lose all lift almost instantly, sinking as if the sea itself has opened up right beneath it. There are no waves. There is no warning. Just a rapid, terrifying descent into deep water. But the danger doesn't stop at the surface as all that methane gas rises. It doesn't just vanish into the air as all that methane gas rises. It doesn't just vanish into the air, it displaces oxygen, creating huge zones of unstable atmosphere directly above the eruption site. In these areas, the air can thin out suddenly. For aircraft flying low or descending unexpectedly, this can be fatal. Jet engines, for example, depend on a very precise mixture of air to function. If you disrupt that balance, even for a moment, the engine's thrust falters. A sudden engine failure over the open ocean becomes much more than a simple mechanical issue. It becomes a race against confusion and gravity. Researchers have actually demonstrated this effect in controlled environments. When an aircraft passes through methane-rich air, it can experience a flameout, where the engines just shut down without any warning. Restarting them requires altitude, time, and stable conditions over the open ocean. Pilots rarely have all three of those things at once. What makes the Bermuda Triangle uniquely dangerous is not just the presence of methane, but the sheer scale at which it exists. Geological surveys have revealed enormous hydrate fields scattered all across the seafloor, some of the largest known on the entire planet. And they don't release their gas gently. Satellite data and sonar mapping have identified vast circular depressions on the ocean floor, craters left behind by previous massive methane eruptions. Some of these craters span hundreds of meters across. This is solid evidence that, at various points in the past, the sea itself has violently exhaled. So, if a plane were flying overhead at the wrong moment, the sequence of events would be swift and disorienting. First, there would be some subtle turbulence, localized, unexpected, and not tied to any visible weather systems. Then, a brief loss of engine efficiency. Instruments might flicker, airspeed would drop. The pilots would try to adjust their power settings, completely unaware that the air itself has changed its composition seconds later. Altitude is lost. By the time the aircraft begins descending back into denser air, its orientation may already be compromised over water. Without any visual references on the horizon, recovery becomes incredibly uncertain. A controlled descent can quickly turn into an uncontrolled impact, and when an aircraft hits the ocean at high speed, the wreckage doesn't always float. High-velocity impacts can shatter planes into fragments small enough to sink rapidly. The Atlantic here is deep, often more than 5 kilometers. The currents moved fast, pulling debris away from the crash site within hours. Any oil slicks disperse quickly, broken apart by the warm, powerful streams of water like the Gulf Stream by the time search teams arrive. Sometimes days later, they find an ocean that has already erased almost all the evidence. This theory could explain some of the disappearances, but not all of them. Catastrophic methane eruptions are still rare events. They're devastating, yes, but they are unlikely to account for decades of incidents that have occurred across all different altitudes and conditions. This means there has to be something else at work. The Bermuda Triangle sits within a region where Earth's magnetic field behaves unpredictably, unlike most places on the planet. This area contains zones where magnetic north and true north align perfectly, and then, just as suddenly, they diverge. Compasses that rely on magnetic stability can become unreliable. Especially during periods of heightened solar activity, solar storms send charged particles hurtling toward Earth, compressing our planet's magnetosphere. In most places, this just causes some minor auroras or brief communication disruptions, but over the Bermuda Triangle, the effects seem to be amplified. Radio blackouts can occur without any warning. GPS signals degrade or fail completely in older aircraft, before satellite navigation became standard. This meant total reliance on dead reckoning, estimating your position based on speed, heading, and time. A small miscalculation here compounds very quickly. Add in the strong underwater currents, like the Gulf Stream rushing northward at speeds faster than many pilots might realize, and the margin for error shrinks to almost nothing. A pilot who believes they are over a certain patch of open ocean may, in reality, be drifting hundreds of kilometers off course. Eventually, fuel runs low. The expected land never appears. By the time the truth of their situation is realized, the aircraft may be too far gone to recover, and still there are reports that even science struggles to explain. Pilots have described flying through sudden, dense fog banks that appear out of clear skies. These aren't normal clouds. They're described as dense, circular formations with sharp, defined edges. Inside, visibility drops to zero. Instruments behave erratically. Pilots have even reported that their perception of time gets distorted. Minutes feel like seconds. Or the other way around then, just as suddenly as it appeared. The fog vanishes. Those who emerge from these experiences often report that their clocks are wrong. Their fuel levels don't match the distance they've flown. They arrive at their destination either early or late. With no logical explanation, these stories are often dismissed as anecdotal, impossible to verify. But when you find similar accounts appearing across decades, from completely unrelated pilots, all in the same region, the patterns become very difficult to ignore. The Bermuda Triangle doesn't need myths or monsters to be dangerous. It has geology, it has magnetism, it has oceanography, it has physics. It's a complex system where small, individual anomalies can stack together. Each one might be survivable on its own, but when they combine, they can become lethal. It's a place where the ocean breathes, the air misbehaves, and the sky can quietly stop making sense. What's the most haunting evidence left behind by the Bermuda Triangle? It's not wreckage. It's sound-crackling radio transmissions, fragmented, incomplete, and often disturbingly preserved in logs and memories, long after the aircraft themselves vanished. These are the last human fingerprints in a place that leaves almost none. What stands out immediately is the tone. Pilots don't scream. They don't panic. They sound puzzled. In one civilian case from the 1960s, a twin-engine cargo plane departed Florida for the first hour. Everything was normal. Weather was clear. Altitude was stable. Fuel was sufficient. Then, without any urgency, the pilot contacted air traffic control. "Heading seems off," he said. "We're adjusting." Controllers acknowledged and asked for his position. There was a pause. The pilot gave coordinates that placed the aircraft impossibly far from its expected route, nearly 100 miles south of where it should have been. Controllers assumed it was a navigation error and corrected him. The pilot responded quietly, "That doesn't make sense. Minutes later, the transmission ended mid-sentence. Radar contact faded shortly after. No debris was ever found in military archives. Similar patterns repeat. Flight 19 is the most famous case, but it's not unique during that training mission. The flight leader, Lieutenant Charles Taylor, reported his compasses were malfunctioning. He believed they were flying over the Florida Keys when in reality they were far to the east, over the open ocean. His voice, captured in transcripts, never rises. He speaks like a man trying to solve a puzzle, not escape danger. We can't be sure of any direction. He says at one point, everything is wrong. This is the moment where training fails. Pilots are taught redundancy, backup instruments, cross-checks, procedures, but redundancy assumes at least one system is telling the truth. In the Bermuda Triangle, multiple systems might fail, or worse, contradict each other. When that happens, pilots default to instinct, and over open water, instinct is unreliable. Several commercial crews who survived near misses in the region later described the same sensation, a creeping doubt about reality itself. One instrument says altitude is increasing, another shows descent. The horizon looks level, but the inner ear insists otherwise. Decision-making slows. Every correction feels wrong. In these conditions, time itself becomes distorted. Pilots can spend long minutes debating course adjustments while fuel drains away. The aircraft is still flying, but the situation is already lost. One private pilot in the 1970s reported entering what he described as a tunnel of cloud, circular and sharply defined inside. His radio went silent. His compass spun freely. He estimated the experience lasted less than a minute. When he exited the cloud, all his systems returned to normal. He landed safely but arrived over half an hour earlier than his flight plan. With fuel levels that didn't match his flight time, his story was quietly filed away. No incident report, no official investigation. Survivors complicate the narrative. If every flight vanished, the Bermuda Triangle would be closed airspace. But some planes do return, and they bring back stories that challenge simple explanations. There are cases where pilots reported complete radio failure while still being visible on radar. Controllers watched the aircraft fly a steady course, receiving nothing but static. Then, moments later, the radar blip vanished too. In other instances, pilots managed to transmit, but they weren't heard. Their signals seemed to bend away, skipping frequencies, arriving garbled or displaced. This phenomenon is known as radio ducting, a condition where layers of warm and cool air trap radio waves, causing them to travel unpredictably. The Bermuda Triangle's unique climate makes such layers common. A mayday call could go unheard, even if transmitted perfectly. And then there are the missing seconds. Several radar logs show aircraft disappearing, not gradually, but in jumps. Their positions update normally, then skip ahead miles at a time before vanishing entirely. This isn't consistent with a crash, nor is it consistent with known equipment failures. Air traffic controllers describe that sensation as watching something slip between frames. Modern explanations suggest radar interference, signal reflection, or data dropouts. And yet, when paired with pilot reports of time distortion, these anomalies take on a more unsettling character, especially because they keep happening. One disturbing trend appears in the final moments of several disappearances. Pilots reporting they believe they are flying over land. They describe lights below, coastlines, even cities, but no such land exists where they are. This isn't just hallucination, it's a phenomenon known as the false horizon illusion, where reflections on the water, stars, or cloud formations create convincing but entirely false visual cues. At night, over the Atlantic, bioluminescent organisms can glow faintly when disturbed by currents. Combined with stars reflected on calm water, the effect can resemble a sprawling city below. Pilots descend, expecting to find land. What they meet instead is the ocean. And because there is no panic, no warning, no realization until the final seconds, there is no call for help, just static. This is why the Bermuda Triangle continues to unsettle us, not because it breaks the laws of physics, but because it exploits the fragile interface between human perception and technology. Planes don't vanish in flashes or explosions. They unravel, quietly, methodically. The final words of the pilots are rarely dramatic. They are thoughtful, confused, rational, which, when you think about it, might be the most disturbing detail of all. In the heart of the Atlantic Ocean lies an enigma, a zone that quietly defeats even our most advanced technology. It's not a place you'll find on any official map. There are no warning signs, no marked boundaries where danger suddenly begins. We call it the Bermuda Triangle. For decades, it's been a symbol of the unexplainable, a source of countless myths and legends. But what if the truth isn't about aliens or portals to another dimension? What if the real story is far more fascinating? A tale of how powerful, natural forces converge in one specific place to create the perfect storm for disaster. When researchers overlaid decades of disappearances with environmental data, a pattern emerges that is impossible to ignore. The triangle sits at the intersection of powerful systems, ocean currents, atmospheric layers, and the very limits of human perception. Each of these forces is benign on its own, but together, they can overwhelm both machines and the people who rely on them today. We're not just looking at the legend, we're rediving into the science that makes the Bermuda Triangle a place where the rules of aviation and physics are pushed to their absolute limit. Let's start with the water. Cutting directly through this region is one of the most powerful ocean currents on the planet. The Gulf Stream, think of it as a massive, fast-moving river within the ocean itself. It can flow at speeds exceeding 4 knots. Now, that might not sound like much, but for an aircraft or a ship in distress, it's a game-changer. Imagine a plane is forced to make an emergency water landing. Even if the ditching is perfect, the aircraft and its occupants will be swept away from their last known position in a matter of minutes. Wreckage doesn't stay put. It disperses rapidly, scattered along unpredictable paths. This makes search and rescue operations incredibly difficult. A search grid based on the final radar contact becomes almost useless immediately. Floating debris, which would normally help locate a crash site, is carried miles away, leaving search teams with an impossibly vast area to cover. The Gulf Stream isn't just a physical force, it also has a profound effect on the atmosphere above it. The warm water heats the air, creating sharp temperature differences between the ocean surface and the air just a few hundred feet up. This forms what meteorologists call inversion layers, thin bands, where warm air gets trapped beneath cooler air. These layers have a strange effect. They can bend and distort radio waves. For a pilot, this means their communication with air traffic control can seem perfectly fine one moment, and then cut out completely the next. For the controllers on the ground, it means an aircraft might flicker on and off their radar screens, like a ghost in the machine. Now, let's look up at the sky. The Bermuda Triangle is located in a part of the world where weather systems can form with terrifying speed and little to no warning. We're not always talking about massive, dramatic hurricanes that you can see coming for days. Some of the most dangerous weather events here are compact, fast-moving, and, especially with older radar technology, nearly invisible. One of the greatest threats is a phenomenon known as This is a sudden, powerful downdraft of air that can slam an aircraft downward with immense force over land. A pilot might see dust being kicked up, or trees bending, giving them a visual cue to react. But over the open ocean, there are no such references. A plane can be pushed towards the water at thousands of feet per minute, and to the crew, it might feel just like a catastrophic engine failure. By the time they diagnose the problem and react, it's often too late. Their altitude is gone, and recovery is impossible. But the dangers aren't limited to storms. Even on a clear day, the skies of the triangle can be deceptive. The warm waters often cause rapid condensation, creating bizarre low-level cloud tunnels and circular fog banks. These formations can completely envelop an aircraft in seconds, wiping out the horizon and any visual reference points. This is where human biology becomes a fatal flaw. Our sense of balance, governed by the vestibular system in our inner ear, is not designed for flying without a visible horizon. A pilot can feel like they're flying perfectly level when they are actually in a steep turn, or feel like they're climbing when they're really descending. This is called spatial disorientation, and it's a known killer in aviation. Modern cockpits have instruments to counteract this, but they only work if the pilot trusts them over their own senses. In a place like the Bermuda Triangle, where instruments can flicker and communications can fail, that trust can erode very, very quickly. Then, there's the issue of magnetism. The Earth's magnetic field isn't uniform, but the Bermuda Triangle is one of the few places on the planet where magnetic north and true north align. This sounds helpful, but the region is also prone to rapid and unpredictable fluctuations in its magnetic field. A compass that was pointing correctly 1 minute might suddenly drift, leading a pilot astray without them realizing it. During periods of high solar activity, like solar flares, these magnetic disturbances are amplified. Now, you might be thinking, don't modern planes use GPS? They They do, but GPS signals are actually quite weak. By the time they reach the Earth's surface, they can be easily disrupted by the same kind of ionospheric disturbances that are intensified in this region. When a plane's GPS signal degrades, its navigation system automatically reverts to its backup, the inertial guidance systems, and, you guessed it, magnetic compasses. If those systems start giving conflicting information, the cockpit becomes a place of confusion and uncertainty, not command and control. Even today, with all our advanced technology, pilots flying through the area report strange, momentary navigation dropouts. Their systems will suddenly reset, recalibrate, and then return to normal as if nothing ever happened. These brief glitches are usually harmless, but they are a reminder that the forces at play here can still interfere with our most sophisticated equipment. Let's talk about the human element. Psychology. The Bermuda Triangle is infamous. Every pilot and sailor knows the stories, even if they dismiss them as fiction. But that knowledge, buried in the back of their minds, can subtly influence their decisions in a high-stress situation. When something goes wrong in this specific part of the world, there can be a moment of hesitation. Is this a real emergency, or just a temporary glitch like the ones they've heard about? A crew might delay declaring an emergency, hoping the problem will resolve itself, fearing they might be overreacting. But in aviation, minutes matter. While they hesitate, fuel is burning, altitude is being lost, and options are narrowing. Stress dramatically increases cognitive load. Simple tasks and calculations become difficult. Tunnel vision sets in, where the crew focuses on one problem while missing another, more critical one. A minor mechanical issue that would be easily managed elsewhere can become a fatal one, not because of its severity, but because of the location and the psychological pressure that comes with it. Finally, there is the simple, brutal fact of depth. The Atlantic Ocean in this region contains some of the deepest trenches in the world, like the Puerto Rico Trench, which is over 27,000 feet deep. When an aircraft or ship goes down here, it sinks fast, and it stays down. Unlike a crash in shallow coastal waters, there is virtually no chance of debris washing ashore or being discovered by chance. The wreckage, and more importantly, the black boxes that hold the final answers, can come to rest miles beneath the surface. Recovering them requires massive, expensive, and highly specialized deep-sea missions. For many of the historical disappearances, this kind of recovery technology simply didn't exist. This absence of evidence is what has fueled the myths for so long. Without wreckage, without black boxes, without survivors, all we are left with is speculation. The mystery is preserved by the crushing depths of the ocean itself. So, has the mystery of the Bermuda Triangle been solved? Yes and no. Modern aviation has made flying incredibly safe. Satellite tracking, vastly improved weather forecasting, and stricter flight procedures have dramatically reduced the number of incidents. The triangle is statistically no more dangerous than many other parts of the ocean. And yet, the anomalies persist. Pilots still report those strange instrument glitches. Air traffic controllers still log momentary radar losses. Planes still occasionally divert from their flight paths for reasons their crews can't fully explain. The Bermuda Triangle doesn't defy the laws of science. It operates in the margins, on the very edge of what our technology and our senses can handle. It's a place where nature stacks the variables, the current, the weather, the magnetism, the depths just tightly enough that failure becomes quiet, efficient, and almost completely invisible. The question that remains isn't whether the mystery will ever be solved, but whether it is simply adapting, hiding in the glitches and momentary dropouts of our modern digital skies.